Everyone, today we'll see what another example is related to what simple harmonic motions. From this one, a 2 kilogram mass hangs at the end of what spring whose constant is 800 Newton per meter. We have given what k constant of the spring and the mass is displaced what distance of what 10 centimeter. Also we have given what the amplitude or the maximum displacement of what such spring is and the list. Then find the velocity at the instant of displacement of 6 centimeters, that is x at x equals to 6 centimeters before reaching what maximum displacement. What would be the velocity? Okay, the second question is that the maximum velocity of what the oscillatory objects or the motions. Okay, from this one we must what figure out the given we have mass m is equals to 2 kilogram and k constant spring which is 800 Newton per meter and just x, that is at instant of x is equals to 6 centimeter, especially plus a positive direction, and the other one is amplitude is given. Amplitude is what 10 centimeter. This is equal to what 0.06 meter and this is equal to 0.1 meter. Okay, from this given quantity we must figure out what free body diagrams. The free body diagram for such equation is we must consider what a spring, and this spring has their own position. Still this is the equilibrium position which is x equals to 0. If we displace, this is what an object after what displaced a distance of what x, which is amplitude in short equals to 10 centimeter. Okay, before that the first question says that what would be the velocity of such oscillatory objects at a distance of what x equals to 6 centimeter. Okay, from this one we must understand the relation between what x or position of what velocity, position of particles or position of oscillatory objects with what its speeds. We know that if x is given by a sine function a sine of what omega t, then v will be a omega cos omega t. From this one, this can be expressed by cos omega t is equals to what root 1 minus sine of what sine of omega t, sine square omega t. Okay, when we substitute this one into this value, we have v is equals to a omega bracket under root 1 minus sine square omega t. Okay, if we insert the amplitude into the square root, we have omega bracket under root a square minus a square sine of what a square omega t. Okay, from this one also we must express this is written by root a square minus x square, since a square sine of since x equals to a sine of what omega t. When we square both sides, this square, this also square, therefore this quantity can replaced by what x. Then we must finally we can determine x at instant of speed using this value, that is root a square minus x square, but omega doesn't given direct, but we can find omega is equal to root k over m. which is equal to root 800 over 2. Then finally we have given that this one is 4, that is 20 rad per second. Okay, then when substitute this one, also A is given, X also given, then V instant is equals to omega already given 20 root what, amplitude is given 0.1 the whole square minus 0.06 the whole square. When you calculate, this value becomes 1.6 meter per second. It may be plus or minus. This is what the velocity at x equals to plus 6 centimeters. Plus, since there is plus, we must cancel such quantities. We must cancel the minus since the value is plus. Okay, this point. Then the Vmax that you have to find is Vmax. Vmax is given by, that is omega, the angular frequency, times what, a square minus x square. But V can be maximum when x equals to 0. Therefore, when substitute 0 instead of x, this one is 0. Then Vmax is equals to what, omega times a. Okay, when substitute such terms, Vmax is equals to omega times a, which is omega means 20 times what, the amplitude is given 0.1, then finally 2 meter per second, which is the maximum velocity at a given instant of what, displacement x equals to plus 6 meter per second. I mean 10 centimeter at highest amplitude, or in short at a point of amplitude. Okay, thank you. It's enough to raise.